Silver oxide reacts with dilute acid, hydrochloric acid, and produce silver chloride. First step, they want us to write a balanced chemical equation for the reaction with state symbols. Okay, so we're going to sort this one out first. Now, what is it? It has to link with, always start with bonding, I told you before. Everyone, when people say silver, the silver there is silver what? Ag plus or Ag2 plus? Is bonding. When people say silver, it's always silver 1 plus. Not 2 plus. Because in bonding, I taught you that silver 1 is more common. And therefore, the Roman numbering in the English, the chemical name, they don't put silver 1. So it starts here. Ag2O based on bonding. They want state symbols, put it in. React with hydrochloric acid. They'll react and they'll form the salt. Mix and match. This acid-base reaction, as you can see. So you got silver chloride. State symbol of all salt, go to the table of soluble of salt and you pick them up, which is here. And this is your water. And this is what you get. You want balancing equation, not balanced, so you got to balance them. And I'll put an HCl here, or Ag not balanced yet. So we balance the metal first. Right? And then I balance here. So 1, 2, 2, 1. I think that's it, balanced. So we are done with it. And you get 2 marks. And this is a question will start to come out. Okay? And used to be, wow, so difficult. It has become a very boring question these days. The heat rate is damn high. Explain why the reaction will not produce a good yield of silver chloride. Meaning you don't get a lot, you only get very little. Of what? Of this salt. Why you don't get a good yield? Very little amount of it. Okay? And the answer goes like this. It's simply because this reactant, silver oxide, when it reacts with hydrochloric acid, it immediately forms silver chloride. And the problem is the silver chloride doesn't dissolve in water. And this is a scenario, in terms of diagram, it looks like this. If blue color is silver oxide, it's just a story. It's covered by this salt that was formed in the reaction called AgCl. It covers it. When it covers it, then you have a problem because the acid, which contributes a H plus that reacts with the base, cannot squeeze in and touch the blue anymore. And the reaction will stop after a while. This is the phenomenon. This is the concept. This is the story. These days, O-level Pure Chem and IP student, I would like to call this a confirmed question. Okay? It could be just MCQ 1 mark. What got such scenario, we'll show you in a short while, right? You have to do with the state symbols. I think some of you, Sec 4, you know, the Sec 3, you have the privilege to go and attend for second time at EBS, right? It was the same question, I didn't change it, right? It's always like that. Also, you heard this before, recently, just 3 or 4 days ago. Right? How do we answer it? It's based on a 4 bullet point, if not 5 bullet point. And here we go. And all the answers, I will phrase it this way. Again, if you never get full marks for this, what a waste. Once you catch the angle, you got to catch it and get the full marks, right? So, I'll say the reaction, the acid base. Okay, first of all, I need to go back here. This is a base, nothing wrong. And this is an acid. Acid react base give you a salt and water. So by right, the reaction, any problem or not, the reaction has no problem, it's good. All right, based on what we learned in acids, yeah, it react. Acid base give you salt and water, nothing wrong. Right. So I will say this reaction or this acid-base reaction produces the salt called AgCl. And the problem is it's an insoluble salt. It doesn't dissolve in water. What happened is then, next bullet point, is based on 4 to 5 bullet points. It forms a protective layer. Over the underlying, meaning it's beneath it. I love this English word. For people that are not very strong in English. So this word is a savior. Over the AgO solid reactant, as you can see in the diagram. And what it does is that it prevents the acid from further reacting with it. So what happened? The reaction will slow down and eventually stop. Or in our space, therefore, your U is low. Because the only thing you get is that thin layer here that you scrape off. That's all the salts you can get. And yes, we expect all this answer in because this 4 to 5 lines include all the keywords to show the phenomenon. Now, why would such a problem exist in the first place if you look at it? Isn't it true that all acid will react with base and give you salt and water? Yes, it does. Nothing wrong. I never say the reaction doesn't occur. They never say it doesn't occur. They say you do not get a lot. Are you with me? So when will we have this situation? Okay, and the situation arises because of this salt. AgCl. It all because of the salt. That's why I say the table of solubility of salts, that table you got to memorize. You don't memorize, the chemistry is in danger already. Because anytime you do need to bring that table out and get the state symbols. Okay? Now, have we done acid-base reaction? Is it all acid-base reaction like that? No. All right, it won't have this problem. Why? Okay, so I'll just take this away and I'll show you again. All right, if you look at it, not every time have this problem on. Let's go back to notes. Okay, so I want to compare. Right? Last time you never say like that. How come now you say like that? If you look at it, there's a difference. Acid-base, right? So, yeah, what do you like? Acid-base reaction. Any one of them, right? Can be this one. Or acid metal. Okay, anyone, right? So, okay, if you look at the titration, right? Acid with a base. Do I have that problem? I don't. Because the salt is soluble in water. If you look at the acid plus excess, we only have three methods of making salts, right? Yes, this is an acid and this is a metal. But if I change it to a base, you realize no difference also. Why? Simply is the salt that's made is aqueous. It dissolves in water. So you won't have the covering. You won't have the layer. Understand what I'm saying, everyone? You won't have the issue. So if I go back to the question, all right, we go back to this question. Where is it? Here. So it's not memorize the example. It is basically any question that come out, I don't care what example. If there is a reaction, I need to make sure, all right, acid-base reaction, I need to check, hey, is that soluble in water or not? I'll give you two more classic example, as in side by side with the one that we just drew. Okay, so here we go. Just now we did this, right? So erase off. So this towards the tail end of salts. That's why these are all the more tricky question, yeah? The more difficult one. But again, we consider very difficult, but now it keep coming out. People find this very boring. So they're going to test you all this. Okay, this is what we have just now, right? Water. Okay, you see, if I use a same acid but I use a different base, I will not have this example. So let's say I use magnesium oxide to react with it. The salt I get is magnesium chloride. You can balance the equation, not very important to me at the moment because I'm not doing more calculation whatnot. Right, it looks like this. Okay, you see what is the difference? Why all this? Why we never talk about it until now? Because all the example I give to you, I never choose an insoluble salt that's formed. Has always been a salt that's soluble. So there's no covering. Everyone okay? Make sense? Both are acid-base reaction. So what you need to focus on is the salt, the state symbols. Everyone okay? It has nothing to do with what is the base or whatnot. It's the salt that's formed. Can everyone? Both of them are called acid-base reaction. But one of them give me high U, one of them give me low U. So this one, I'm going to get a lot. I'm going to get high U. Whereas this one in black, right, I'll get very low U. I won't get a lot of it. Everyone okay? Not that don't have, sure have, because they do react. But after a while, it stops. Because got covering, got protective layer. That is a story. Okay, I mentioned again, the next WA you tested on this, right? And it lands on me, right? I will make sure this recorder is forward to you first, and your parents want a copy or forward the recording to them. I repeat myself, this is a confirmed question if you ask me. Okay. Anyone don't understand anything? Time to voice out. And let me know. Sorry, go again. Why go protective layer? Because of the state symbol. Because it's a solid. So it coat onto the other solid. It coat on it. Why it becomes solid? You cannot ask me why it becomes solid. Instead, you will say why in reality it's solid. People done experiment, they realize it's not solid. It's insoluble. How come then? Then how do we know? We have to memorize the table of soluble salts. Is it okay? Okay. People do experiment, this salt cannot dissolve water, and it coat on it. Okay. Okay. And therefore, for the same reason, if you realize, that's why for such salt called AgCl, you realize what is the method we choose. We will not choose the method called acid, or rather acid over here. Once again, plus base. In my flow chart, do you ever see me doing this? Give you a salt and water. Would I have done this experiment? I won't. I won't choose this to get this salt called silver chloride. I'm not going to use this method. And what did I say about the method we use? I say follow the step. Question 1. Ask yourself, is a salt soluble in water? And we realize it is insoluble in water. And therefore, I say we do precipitation method. Because precipitation method won't have this problem. My flowchart works very, very well.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.